Hey guys, just wanted to show you a quick way. I was planning on using some Pogo pins for programming. You get some Pogo pins kind of like this. Got these ones with the ends that bite in. And I was trying to figure out a way to be able to program boards quickly without putting a header on them. And came up with this way. Use a couple of boards, you get a variety set of these standoffs. I got these on eBay for pretty cheap. And basically what I'm planning on doing is I haven't soldered these in yet, but they're all loose. And you just put a bunch of spacers here. And I put these spacers here, solder these in, put some smaller spacers in here. So next time you put the board on top, there'll be a little bit less room and they'll need to be able to compress. So I'm going to try this out, and you could either just directly put on a header or some sockets. They don't fit, well, look, they do fit pretty well actually. They might need, they probably don't fit exactly right away, but you could mess with them and get them fit on there, pin them out the right way. They'll be the opposite, of course. And or else you could, put a board on there, screw it in, put a header on here, so you can just plug it in right away. That's probably the easier way. If you have boards, spare boards, do that maybe. But I'll let you know how this works out. I think it's promising. So just another idea of how to use the Pogo pin and the header. My connection is just held on by force, but you could solder it. You start by removing this plastic cover. And take the Pogo pin, and you might, depending on your headers, you might have to expand this a little bit. And then take the Pogo pin, that goes in there. A little bit of flux, a little bit of solder that'll hold it on permanently. Remember to put your heat shrink tubing on before. Well, I suppose if it's large enough, you could slide it on the other side. But yeah, little solder that'll hold that better. Little heat shrink tubing if you have it. And you'll have a better connection, a little bit less prone to falling off. Alright, so now I've got it pretty much all finished up. I'll show you what I did. With the help of another kit, one of these guys makes life a little bit easier. You don't need it. But I've attached the other female header to the other side of the Pogo pins. Doesn't want to go on too easy, but once you get it on, it's pretty snug. And all the contacts are making contact. And then just for support, if you have more boards, you can put another board here. Stop it moving around like that. So then how it should work is, well, one other step too is I shortened the size of these standoffs down by 2. I had these ones and I went down to here to allow for some of the springs to be more compressed on the Pogo pins. So then basically what you should be able to do is to just pop on a board like that and just hold it down like that, and that should compress the Pogo pins like that. You should be ready to program. Obviously this one doesn't have a microcontroller on it, so it won't work. But with the help of this other kit here, makes life a little bit easier. You can pin out the other pins to the correct ones, so when it's time to program, all you need to do is just simply plug it in. But yeah, it seems like it worked out. I'll have to try it out as soon as I populate another board. So I'll let you know how that goes. And just as a last step, you're going to want to verify all your pins, make sure you didn't make any mistakes. So on this, it's fairly easy. We have the pin out here and we have the pin out here, so just buzz one out with the ground here and ground here. Make sure, there we go. So make sure you have the right pin out. Don't blow up your microcontroller just yet. Alright, well, I've made a couple changes to the jig in order to not have to sacrifice another board. I removed that, 3D printed a base, also added a zip tie for a little bit of strain relief. But it seems like it's working pretty well. Here I've populated this board with a microcontroller. You might recognize it, quite popular microcontroller. So all we need to do is apply a little force, push down. If you want to do testing, you can just simply add some more of these standoffs and keep the board on the jig so you don't have to apply any pressure. So I'll just upload a sketch here. I've already done it successfully, so go up here, and the way I usually do it is, oh well, one other thing. Applied a little paint here to this side, so I know that the notch corresponds with that. I can just plug it in. So we have our programmer. And to program, simply hold Shift, and then you'll see the dialog, upload using programmer, and it'll compile, and it will upload. So the jig looks like it's working. I'm using internal oscillator on this board, so no crystal was needed. But yep, code's on the board, and everything is working. And in case you were wondering what this board is, this is a IR remote, programmable IR remote project I've been working on. First I designed it to run at 8 megahertz, and then 1 with this board. It seems to work alright still, so you can use it at lower voltages. This is set up to run on a lithium-ion battery. And then here we have the 3D printed case that I've designed, and seems to have worked out pretty well. Thanks for watching.